Hi, future doctors. Welcome to the next class. In this class, we will discuss about electric field intensity on axial line and equatorial line due to dipole. So, what is the dipole? We said means two equal and opposite charges. This is positive charge. This is negative charge of same magnitude. If it is 10 coulombs means if it is going to be minus 10 coulombs. Separated by very small distance. So this is, let us assume center to this charge is at a distance A. This is for our convenience we are taking. Therefore, total dipole strength is going to be 2A. So what is the direction of dipole moment we said? Direction of dipole moment is always from negative to positive charge. This is nothing but dipole. On its axial line, let us assume the line which is passing through the center and parallel to its length is nothing but axial line. At this point P, I want what is the electric field intensity. So we came to know already because of one charge, positive charge, electric field intensity at a distance small r, kq by r square. That formula we are going to use here. Now this point P from center, it is at a distance small r. Now because of negative charge, what is the electric field intensity at point P? So because of negative charge, electric field will be towards. Towards means this is going to be left side. E minus. E minus refers electric field intensity due to negative charge at point P. Next, what is the distance from negative charge to point P? So if you see this diagram, so what is the distance means? This total distance O to P is R minus A. Now R minus A is the distance of point P from negative charge. Now what is the electric field due to this negative charge at this point P at some distance means, now in place of R you have to apply R minus A. Therefore E minus is equal to KQ by R minus A whole square. Understood? Just it is at a distance R minus A. This direction, because of this is negative charge, it is coming towards left. Next up. So at point P, because of positive charge. Now from here, what is the distance? Positive charge to point P. So O to P, it is going to be R. From O to Q, it is going to be A. Therefore, it is going to be R plus A. Because of positive charge at point P, electric field intensity will be away. E plus. E plus is nothing but electric field due to positive charge at point P. Now this point P is at what distance means R plus A. Therefore, E plus is equal to KQ by R plus A whole square. These two formulas we got from here, general formula. Electric field due to point charge at some distance R. Now see here, you got two directions. One is right side, one is left side. Now angle between this is 180. Therefore, you have to find resultant by subtracting. So E at point P or axial line is going to be, so which minus which we have to write, which is more, which is less. R minus A is less. Therefore, this value is going to be more. R plus A is going to be more. Therefore, this value is going to be less. Which is higher value means here E minus is higher value. Therefore, E minus minus E plus we have to do. What is E minus here? KQ by R minus A whole square. KQ by R plus A whole square. Simple mathematical derivation you will get. Here our intention is not to derive the equation. Therefore, directly after getting what we are going to get, because we have to play with final equation, not this. Just how it is coming, what is the resultant direction to come to know, I have explained all this. Now, what is the final answer means here? 2 kp r by k means 4 pi epsilon naught. So, r square minus a square whole square you will get. Now, what is the resultant electric field intensity direction? Here, E minus is more, E plus is less, I said. Therefore, resultant electric field intensity will be towards left. Towards left in the sense, in which direction dipole moment is there? In that direction, electric field intensity will be coming. So, for short dipole, this is for long dipole. For short dipole means this length is going to be very small. Length of the dipole is very small at the time. So, A is less than R. If A is less than R, A square can be neglected. So, why it can be neglected means 1 and 0.1. So, if you made 1 square 1, if you made 0.1 square 0.01. Therefore, if you are making smaller value square, its value is very small. Therefore, we can neglect that. What you will neglect here? A square you have to neglect, because short dipole means A less than R. At the time, so 2 kp R by R square whole square. So R power 4, 1 R will be cancelled. 2 kp by R cube. This is the electric field intensity magnitude on axial line. So electric field intensity on axial line is inversely proportional to R cube, distance from center. What is smaller here? Distance from center to point P. Now, what is its direction? E axial will be in the direction of dipole moment. E axial is parallel to, both are in same direction. Here, dipole moment is left side. Therefore, electric field intensity on axial line is also left side. So, if we have taken dipole like this, let us assume negative charge here, positive charge here, minus q plus. Now, what is the direction of dipole moment? Right side. Therefore, at this point P, resultant electric field also will be right side. Always electric field intensity on axial line and dipole moment will be in same direction. Here, if we have taken, let us assume left side, if we are taking that point P, if we are taking it left side. Now, what is the direction of dipole moment? Left side. Therefore, resultant electric field intensity also left side. Now, what is the angle between electric field intensity on axial line and dipole moment? What is the angle means? Theta is going to be 0. Now, what is the dot product or cross product they are going to ask? E axial cross P bar. So, what is the angle we set? 0 we set. Therefore, cross product of two vectors AB sin 0, 0. So, already we came to know A bar cross B bar is equal to AB sin theta n cap. Here in place of E and B, E axial, P they gave. Therefore, it is going to become 0. Cross product of electric field intensity on axial line and dipole moment. Dot product is going to become maximum. So, this is about electric field intensity on axial line. This formula you should remember. For short dipole means you have to use this formula. For long dipole means you have to use this formula. So, this is about axial line. Now, we will see equatorial line. Now, electric field intensity on equatorial line due to dipole. Again, positive charge, negative charge. These two got separated by distance A. So, total dipole distance length 2A. What is its direction? Dipole moment direction is negative to positive always. Now, equatorial line means the line which is passing through its center perpendicular to its plane. It is at a distance small r from O to R. So, because of positive charge, electric field intensity will be away. Is it visible? Yes, not visible. I will draw little bit. Same. Just we will draw here. So, positive charge, negative charge, both got separated by distance small a. Now this is going to be equatorial line from O to this point P is at a distance smaller. This point P. Now because of positive charge, electric field intensity will be at point P, electric field intensity will be away, that is E plus. Because of negative charge, electric field intensity will be towards, that is E minus. Now what is E plus, what is E minus? Let us assume this is A, B, this is P, this point is going to be O. Now what is AP? AP will be coming, if it is A, if it is R, this is going to be root R square plus A square. Therefore, E plus is going to be KQ by root of R square plus A square whole square, because of point charge at some distance R at a point P, electric field intensity is KQ by R square. In place of R, how much is there here? Root R square plus A square. This is also same, root R square plus A square. E minus also you will get same, square and root will be cancelled. So KQ by R square plus A square. Here also you will get same, directly I am writing R square plus A square. Now what is the resultant of these two? How it will be coming? To find that resultant, let us assume this angle is going to be theta. If this is parallel line, these two parallel lines, if it is theta means this is also going to be theta. Correct? This is also going to become theta. Correct? Now E plus, if you resolve E plus into two components, E plus cos theta, E plus sin theta. Same like that. E minus if you resolve, E minus cos theta, this is E minus sin theta. How they will ask problems, how you will get resultant, that is very, very important. So on equatorial line at point P, so resultant at this point, two vectors in same direction, E plus cos theta plus E minus cos theta. Here E plus and E minus both are going to be same. Let us assume that is going to be E. Therefore, E cos theta plus E cos theta, that is going to be 2E cos theta. So from the diagram, what is cos theta? Cos theta definition. Cos theta is adjacent side by hypotenuse. Therefore, A by root R square plus A square. Again, already we came to know E. That is nothing but 2 KQ by R square plus A square. A by R square plus A square whole power 1 by 2. So finally, you will get like this, on equatorial line, Kp by R square plus A square whole power 3 by 2. This is for long dipole. Kp by R square plus A square whole power 3 by 2. If you want for short dipole, what you will get? For short dipole, what is the condition we said? So A is less than R. Is it visible? A is less than R, yes. A is less than R means what will be neglected? A square is neglected. Whenever A square is neglected, if you write this formula, Kp by E equatorial, Kp by R square whole power 3 by 2, Kp by R cube, isn't it? So this is also inversely proportional to R cube, correct? Now E on equatorial line is going to be Kp by R cube. What you got for axial line? E on axial line is equal to 2 Kp by R cube. These two are for short dipoles. This is also for short dipole. Now see the resultant direction and what is along y axis. This is along x axis. Now what about y axis means? These two are E plus sin theta, E minus sin theta. Therefore those two are equal and opposite. Therefore resultant electric field direction along y axis is going to be 0. Now what is the direction of this electric field means? Right side plus I cap. What is the dipole moment direction? This is going to be left side. Now, E equatorial line anti-parallel with dipole moment. Now, what does it mean? Angle between electric field intensity on equatorial line and dipole moment is 180 degrees. Both are going to be opposite. So, equatorial line electric field intensity is in opposite direction with dipole moment. They will represent with minus sign. This negative sign indicates E equatorial line and electric dipole moment both are in opposite direction. So if it is left side dipole moment, electric field intensity on equatorial line will be right side. If it is an axial line, if it dipole moment is left side, on axial line it will also be left side. So on axial line means both will be in same direction, electric field intensity and dipole moment. Equatorial line means both will be always in opposite direction. So now once you can see all the equations once, if dipole moment is like this, P bar right side, so electric field intensity on axial line is also right side. So electric field intensity on equatorial line will be quite opposite to dipole moment. So on axial line, what is the formula? For short dipole, you can remember 2 kp by r cube. On equatorial line, what is the formula? Kp by r cube. So in place of Kp by r cube, what we can write? E equatorial line. Therefore, E axial is equal to 2 times of E equatorial line. Sometimes they will ask ratio. You should remember carefully. One of the year they asked how the electric field intensity due to dipole will be varied with distance. Either axial line or equatorial line, it is going to be r cube, inversely proportional to r cube. So at any point, this is neither on axial nor on equatorial line. This is positive charge, this is negative charge, both are equal and opposite, separated by distance 2a. Now we discussed on axial line, we discussed on equatorial line, but now this point P, neither axial nor equatorial. So at that point P, what is the electric field intensity means? If you substitute, you will get these two. So Kp by r cube. So very important formula, root 1 plus 3 cos square theta. If it is on axial line, this theta is going to be 0. If the theta is 0, this point will be coming on axial line. Therefore, if theta is 0, E axial is equal to Kp by r cube root 1 plus 3 root 4. Again you will get this one. Equatorial line, this r is going to be like this. At the time theta is going to be 90. If theta is 90, cos 90, 0. Therefore, E equatorial line, Kp by r cube. Here you will get 2 Kp by r cube. Same values you are going to get. Therefore, this is the formula for E at any point. What is the resultant direction also they will ask. So one formula will be there, tan alpha is equal to half tan theta. So this is the electric field intensity at any point direction. Alpha and theta relation will be coming like this. In projectile motion, so many times you will get this relation. So we will discuss about this one after discussing projectile, how this relation will be helpful for so many equations. So this is at any point electric field intensity. At any point means definitely they will give this theta with the distance, how much angle it is going to make. If theta is 90, that is going to be equatorial line. If theta is 0, that is going to be axial line. Okay. So once we can practice these equations,